three-dimensional model. So we have an airplane that's traveling, right? Constant altitude, 720 miles per hour, anti-aircraft. So there's this missile that's fired from here, and it's going to intersect the plane, right? So this is the plane. This is the missile. Yep. And it says, what does it say? The angle between the flight paths is 145 degrees. So it's telling you that this is what? 145 degrees. And it's saying that this is 720 miles per hour, right? What's the missile? Does it tell you? 1,200 miles per hour, right? And it says the angle between them is 145. At the instant the aircraft is 3 miles away from the point P, the missile is 5 miles away. It's 1,200 miles an hour. At that instant, how rapidly is the distance between the missile and the aircraft decreasing? So if we're trying to find the distance between the plane and the missile, we need to draw a line that represents that. So we need to complete the what here? So that's the distance we want, right? So there's our picture. What do we know and what do we want? Well, what's one thing we know?
Label the sides first, like
yeah, let's call this P and let's call this M, okay? So what's one thing we know?
PM, DT equals 7.
dP dt is what?
Yeah.
What is dP dt?
Yeah.
Negative 720. What is dm dt?
Negative 1,200.
Negative 1,200. It's getting smaller, right? Because they're getting closer to that point, right? Do we know? And then what do we want? dd.
Call it theta, by the way.
Do you want to call it what? Oh, theta? Well, theta's the same. Yeah, we can call it theta, yeah. Let's call this A, by the way. Is that okay if I call that A?
Theta, yeah.
Hold on. I'm just going to call this right here A. So now what do we... So we know dA. We want dA dt when what?
P is 3.
When P is 3.
And
M
M is 5.
is 5. Is it M5?
I think so.
Yeah, 5 miles, yep. And theta we know is what? Oh, we also know theta is what? Theta state, thank you, is 145 degrees the entire time, right? So we have written down everything we know and we want, so now we need to write an equation that links what we know and what we want.
Yeah.
So what's that equation going to be? Well, we know that a squared is equal to what? P squared plus minus 2 PM cosine of what? Of theta. Are there any of those? So, okay, so we're there, right? Nice.
Or we have to memorize this equation.
Yes, yes, you have to know the law of cosines. Absolutely. What I'm going to let you plug in one number. What's one number that's static the entire time? For the entirety of this problem.
145.
So I'm just going to put 145 there. Now what do you have to do? You have to take the what of both sides, the derivative in terms of time, and then plug things in. So Chris, derivative in terms of time. Can you tell me what the derivative in terms of time is? What's the left side going to be?
So we got 2a
Times.
d82.
Got it. Can someone tell me what the next thing's going to be? Chris. Sorry, Arvin. What's the next one going to be?
2p
Yep.
dp dt.
Yep. Andrew, what's next? Plus what?
2m
Yep.
dm dt.
Exactly. Alex, what's next? What do we have to use next? What rule do we have to use next? 2 cosine 145. What differentiation rule do we have to use now? To differentiate this, what rule do we have to use?
Oh, product.
Thank you, Alex. The product rule. So what's the product rule going to tell us that derivative is? So it's dp dt times plus. Yeah, I like keeping the order the same, so I would say, I don't want to erase this, but I will. I would say p times what? dm dt. I just like keeping it in the same order. Is everybody okay with this right here? What can we cancel out of all of them? What's in all the terms? 2. So we could just cross the 2's out, right? Do we know some of these already?
Yeah.
Negative 720, where's that going to go? That's dp dt. So where's that? Right there, right?
Yep.
What about dm dt? Is that there?
Yep.
That's there.
And then we know M.
And we know m. We know m and we know p, right? So let's plug some stuff in. So we know a. We don't know dA dt, right? What's p going to be? Or what? It's when p is what?
3.
So it's 3 times, what's dp dt?
Negative 720.
20 plus m, which is 5. What's dm dt?
Negative 1,000.
200 minus cosine of 145, right? And then what do we have here? What's dP dt? 20 times m is 5 plus what? 3 times negative 1200. which is the thing we are trying to solve for? What's the thing we're trying to solve for? We're trying to find this thing, right? There's only one thing left that we haven't found. What is it? That's what we need to find, right? What triangle are we trying to solve? Well, this is 3, this is 5, and this is the length we want, right? And that angle is what? What is that? 145 right there. So what do you need to use to find that? No, it's not a right triangle, so you can't use the Pythagorean theorem.
10.
Nope. What do you have to use to find that? Law of cosines. Use the law of cosines right now and find me A to 3 decimal places. Go. Where do we plug that in now? Where do we plug in 7.653? Into A, right?
Yeah.
So then you just have to plug in a long string of commands, and do you have an answer? So dA dt is going to equal this right there over what?
7.6.
One thing that's really important, everybody, this is really important. Generally speaking, do everything you can to not round until the end. Do you understand? If you just plug in 7.653, that's probably good enough. But try not to round until the end if you can. If you can. Do you understand? Okay, as practice, tell me what the final answer is to 3 decimal places. I want the final answer right here. What's dA dt? Do that a reasonable answer? Is that justified for me? Justify that that's a reasonable answer. Yeah.
Well, it's like a missile in a plane.
So yeah, they should be high, right? Sure, that's the first level. Give me another reason why that's a reasonable answer.
Because they're getting closer and closer.
They're getting close. It should be negative. What about specifically, what's the fastest they could be heading towards one another?
Those 2 speeds combined.
Yes, exactly. If they were pointed at each other, 1,200 and 720, they'd be heading toward each other at 1,920 miles per hour, right? So whatever number we get should be less than that. So the speed they're increasing is so it should be greater than negative 1,920. They're almost head on, so it's pretty close, right?
Yeah.
It's almost.
Oh, that makes
You see what I mean, everybody?
So if it was like
Wait, can you explain that?
Look, if a car's going 60 miles an hour
Yeah.
and a car's going 50 miles an hour, how fast are they coming towards each other? 110 miles an hour. You add them together, right?
Yeah.
Look at the speeds. What are the speeds of the plane and the missile? 720 and 1,200. If they were pointed at each other, they would be, their distance between them would be reducing at 1920, right? Look what we got. 1836. It should be a little less than that, right? Or more because it's negative, right? We could do this question where the missile's catching up, that kind of thing.
So if it was like 180, like if they're directly facing, like if the degree of theta was 180.
If they were at 180, you could do it that way. It would be just subtracting it, right?
Yeah.
It'd be so it would still catch up, right?
I'm guessing that later on in the year we're going to be doing this.
Your choice right now. Let's go to 20th, right? 20 right here. I put these in. Did you see the related rate AP questions? They're pretty cool. Pretty cool. I gave you, where is it? Oh, man. There it is, right here. Here are your choices. We can do these as a group. We have air being pumped into a spherical balloon. We have 2 people or 50 feet apart. We have aircraft question with angle. We have implicit differentiation. We have an FBI agent with a powerful spyglass. We have a flood lamp. We have a receptacle in the shape of an inverted square pyramid. We have a large red balloon. We have a fish. Which one do you want to do? Watch. Okay, so you know this. You know volume is equal to, oh yeah, can someone hit the freeze button? It's the remote. Hand me the remote up there on the, thank you. Cubed. Are you okay with this? Take a look at that. Ask questions right now if you're not okay with it. It's an h squared right there and an h right there.
Oh.
Are you okay with this?
So you just pulled it out.
Are you okay with that? Why is it really nice to have just that now? How many variables do you see? Well, excuse me. How many input variables do you see?
2.
Input variables. H is the input variable, V is the output.
1.
Why is this nicer than what you guys were dealing with? 2, yeah, you could eliminate by finding the relationship, right? But again, the only reason I saw that, everybody, is because eventually what did you guys have to do? That purple thing, right? So it's like, oh wait, look, I was having you guys differentiate and plug it in at the derivative step. Well, you can just plug it in right there. Let's see what happens when we do it this way. Let's take the derivative now. Do we need the product rule?
Yeah. No.
Do we need the product rule?
Yes.
No, we do not. There ain't no 2 variables being multiplied together right there, right? You like that? So what does dv dt equal to, Chris?
0.2.
No, yeah. Oh, that's true. No, that's true. But let's do the differentiation. dv dt on this is equal to what?
3 over 25.
3 over 25 times
3
h to the
dHdt.
h squared dh dt, right? Which one are we trying to solve for? dh dt. When h is... So what can we plug in? 2. And we know that dv dt is 0.2. So we have 1/5 is equal to 3 over 25, right? Times 3 times 2 squared times dh dt, right? Is that algebra a little bit simpler than what you just did? A little bit. Let's just make sure we get a clean answer here. So what do we end up with? 1 over 5 is equal to 3 times 4 over times dh dt, right? So what does dh dt equal? 1 over 5 times the reciprocal, which is what? 25 over what? 3 times 4?
36.
Yeah, but that cancels with that, turns it into a 5. So you get dh dt is equal to 5 over 36. Is that exactly what they got over there? Yeah. Is that a quicker way to do it? Absolutely. But again, just because there is a simple way of doing it doesn't mean that the simple way wasn't hard to find. The key thing here to realize, if you could take away one thing, if you have two variables as your input, like S and T, find a relationship between those two variables. It's not just going to be the formula there. It's going to be, oh, remember the similar triangles and the shadow problems, everybody? You would have like the person walking, right? So you'd have like the lamppost X and A, and maybe the height of the person. You know that X plus A over L is going to be equal to what? This over this is going to be equal to what? A over H, right? The similar triangles. There's a secondary relationship that you need to remember. Same thing over here. But again, just because this was simpler doesn't mean it wasn't hard to find. This would just be X, this would be 2X.
Okay.
Just be very careful.
You find another relationship.
Yeah, to add into it, right? So it would be 2x squared. You can do it, just be real careful. And I will tell you that this is a common, when you look at, let me show you, in the AP questions that I gave you, in the share space, did you guys actually look at any of these? So look at that. There's a lighthouse right there. There's a cone. It happens all the time that you need a secondary relationship. Let me see if I don't know if I can find one here. Do you want to try a multiple choice one? Sure. Here you go. Let's try this one. This looks fun.